Okay, so on your class page, you've got, here's your topics page. I put a new topic on conic sections. We were supposed to start circles and ellipses yesterday. We didn't. If you go to this, you'll see, first of all, the timeline. So here we are on the 3rd, right? We're a day behind. The test is a week from today on conic sections. So I'm going to go a little bit quickly today. The reason I'm recording this is because we've got a number of people out. If you don't get the notes down quickly enough, you can go back and find them. I'm going to save the audio file and also the stuff I put on the whiteboard as a PDF. So you can go back and look at them. Today we're going to do circles, ellipses, and hyperbolas. I'm going to go fast. On your class page as well, I've got this document. It's sort of a 2-page document. I've titled it Everything You Want to Know About Conic Sections, but We're Afraid to Ask. Okay, so everything we're going to talk about today is under circles. Circles, the general form, standard graphing form, completing the square. We're also going to skip parabolas. Parabolas are going to come in a couple of days. And we're going to do ellipses, right, and hyperbolas. So all the stuff you need is here. Hopefully you're going to take some notes. A lot of this will be a review from Algebra 2. Okay? We do have a final exam in 4 weeks, so I'm also going to give you some exam review materials today. Okay? Circles. And I've got some scribbly notes I wrote. Okay, so basic ideas first of all. If this is our XY axis, then all the discussion in this is rectangular coordinates. There's no polar stuff coming in today. Okay. If you have a circle in the XY plane, the first thing that's pretty obvious is y is not a function of x. So y is not a function of x. Why? Because graph fails vertical line test. Vertical line test. Remember, the vertical line test for functions is if you have a vertical line and you move it back and you look at the graph, it can only hit it in one spot because it hits it in 2 spots, not a function, which causes some problems if you're trying to put this on your calculator. If you're in function mode, you can't put a circle in. So how might you try to do it? Well, you might want to try the top half, right, is a function. Enter that in as y1 and enter in as y2 the bottom half, then you can get the full circle. And some of that's in your textbook. All of this is in section 1.5 in your text. And if I have time, I'll pull that up and look at it. Okay. Let me make a couple of other comments about the graph. The graph may or may not intersect the x-axis. Here I have a couple of x-intercepts, and I have a couple of y-intercepts, but that doesn't have to happen. Obviously, we could have a circle where it may hit one, but here I'm hitting the x-axis and the y-axis, but suppose I had this, where the circle's hitting the x-axis, but not the y-axis. That's possible. Right? So you might have x-intercepts and no y-intercepts, or you might have y-intercepts and no x-intercepts. You might have no intercepts if the circle is out, sitting out here somewhere. Okay, so we're going to have to think about how you get intercepts. Okay. Let's look at some basic ideas. We've messed with this circle forever. X squared plus y squared is 1. That's our unit circle. And obviously we have x-intercepts and y-intercepts, and you should know this is 1 and negative 1, 1 and negative 1. Okay, so nothing really strange about that. Let me bump this up a little bit. Instead of a unit circle of radius 1, radius is 1, let's change this to a circle radius 5. So this now becomes 25, And now the radius is 5. Everybody okay with the radius 5? Yeah, 25? Okay, so in general, if we look at the textbook calls it standard form or a graphing form. X squared plus y squared is r squared. This is the radius, and this is a circle centered at the origin. Centered at the origin. Okay, so no great shakes there. But most circles are not centered at the origin, so let's go ahead and go with another basic idea. Let's replace x with x minus 3. So I had x squared plus y squared is 25, but now I got x minus 3 squared plus y squared is 25. So let's think about how that affects the picture. So here's our original circle. It was centered at the origin with a radius of 5. Okay. What does replacing x with x minus 3 do to the picture? It moves it. Which way? Up, down, left, or right? Right, right, right. How much? 3 units. Okay. So I should be able to think of my center here now is going to be moved, so the center is over here at 3. Okay. So what I've done is this is now the center at 3, 0. And so this is a horizontal shift. Remember, we did all these shifts earlier in the year. And so this is a shift right 3 units. Whenever x is replaced with x minus 3, that's a shift right 3 units. So there's our new picture. Got it? Now, just looking at the picture, does this circle have x-intercepts? Yes. Does it have y-intercepts? Yes. Let's find them. Okay, so let's do the x-intercepts first. Now, the x-intercepts are on this line. The equation of that line, the equation of any horizontal line, is y equals 0. Right? So to find, we're going to find these guys first. To find the x-intercepts, let's write this down. To find x-intercepts, set y equal to 0. So you go into your equation, here's the equation, and you make y equal 0. Well, that's pretty easy to do. This equation now becomes x minus 3 squared plus 0, I don't have to write that, equals 25. Everybody good so far? I just made y 0, so that goes away. That's these two spots. We know that y is 0. We're trying to figure out what the x is. Now, actually, this isn't a hard problem. The x, remember, was here, but we moved it 3 to the right, so the new x-intercept is going to be 8. We know that. So let's pretend we didn't. How do you solve this equation? So the best way you should solve this equation is to take the square root of both sides. So the square root of x minus 3 squared is x minus 3, and the square root of 25, let me be very explicit there, is plus or minus the square root of 25. Whenever you take the square root of both sides of an equation, don't forget the plus or minus. So we get x minus 3 as plus or minus 5. And then at this stage, we would move the 3 to here. So x becomes 3 plus or minus 5. And then that's obviously two numbers. 3 plus 5 is 8. And 3 take away 5 is negative 2. And so this is 8 here. And this one here is negative 2. Negative 2. So we found the two x-intercepts pretty quickly. Let's find the y-intercepts. Now, to find the y-intercepts, we're chasing down this line. This is a vertical line. All vertical lines have an equation of the form x equals, and the equation of the y-axis is x equals 0. Okay, so we know that this point, this y-intercept, has 0 for x, but we don't know the y yet. Okay, and we also have 0 up here for x, but we don't know the y yet. So let's go ahead and find the y-intercepts, and let me just take all this green away. Okay, so to find y-intercepts for any equation, and by the way, this works for circles, ellipses, parabolas, hyperbolas. If I say find the y-intercepts, just take the equation and make x 0. That's all you do. And that will tell you where it crosses the y-axis. Okay, so to find these two y-intercepts, set x equal to 0. So you go to your equation, x is 0 now. So we have 0 minus 3 squared plus y squared is 25, right? So we have negative 3 quantity squared plus y squared is 25. And again, this is sort of reminiscent of what we did very, very early in the year. You weren't here, Lenny, but one of the first things I did do in the very first class we come back from summer is tell me what that equals, and you would say, that's wrong. So it's not 9, it's negative 9. This is 9, right? Okay. So we're sort of emphasizing that here. 0 minus 3 in parentheses is negative 3, and negative 3 quantity squared is 9. 9 plus y squared is 25. Go ahead and do the subtraction. Y squared is 16, so y is plus or minus the square root of 16. Y is plus or minus 4. So go back to your circle, and we now have these two y-intercepts, okay? So that's 4, and this is negative 4. Y is plus or minus 4. Okay, comments at this stage? Okay? Now, I've got one other idea here is sometimes you will not have the equation of the circle in the graphing form. You'll have it in what's called the general form. So this is on your handout. Again, you can go right here, the general form for a circle. Let me just point that out to you right here. The general form of a circle is ax squared plus by squared plus cx plus dy plus e equals 0. Okay, so I'm going to give you an equation like that. For circles, a and b have to be the same. They have to be the same number. Okay, so here's your general, G-N-E-R-A-L, general form for a circle. And this is the example I want to use. X squared plus y squared minus 6x plus 8y is equal to 0. If we go back to the handout, you'll note that the A and the B are 1, right? The C and the D, I've got those. The constant here happens to be 0 in this example. Right, there's a constant 0 right here, but that doesn't have to be. That can be any number. But let's go ahead and work with this one. This is the general form for a circle. The A and B are the same number. They're 1 in this case, and they're both positive. So that tells me it's a circle. There is a comment on this handout that if A and B are different numbers, circles, okay? If A and B are the same sign but not equal, then you get an ellipse. We'll do an ellipse in just a little bit. If A and B have different signs, one positive, one negative, then you have a hyperbola. Okay, so just by looking at the general form of the equation, I know that this is a circle. If this were a 4, I know it's an ellipse. Same sign, different numbers. If this happened to be a negative 1, I know this is a hyperbola because they're opposite signs. So you can tell very, very quickly your conic section just by looking at the coefficients of x squared and y squared. Okay, but this is the one we're dealing with. Now let's draw a picture. Okay, so we now have to sort of think, what is the graphing form or the standard form of a circle? It looks like this: x minus h squared, y minus k squared, and r squared. If you can get this equation in that form, then the center is going to be the ordered pair hk, and the radius is going to be r. Okay, so somehow we have to get the x things together. We have to complete the square to do that. You did this last year. I'll do a couple of examples of completing the square today. Once we get it in this graphing form, or the standard form, then we can find the center and we can draw a picture pretty quickly. Okay, so let's go ahead and complete the square. Now, as you do this on your paper, you should do the following. You're going to rearrange the terms, x squared minus 6x, leave a gap. I'm going to fill that in just a minute. And we have y squared plus 8y, leave a gap there. And then whatever's on the other side. This happens to be 0, but this could be 10. If this were 10, we'd have 10 there. But as it is, it happens to be 0. So let's just work the problem the way it was given. Okay, now to complete the square, there's a process. We'll do the x's first. Okay, so we need to put a number there. The way we're going to find the number is you take half of that coefficient. Half of -6 is -3. You have to square that. What's -3 squared? Well, I want to square the number -3. That's 9. That's what we're going to put here, plus 9. Okay? We're squaring the number -3. I didn't say the opposite of 3 squared, which would be -9. Okay, we're going to do the same thing over here. We're going to put a number here. You take half of that coefficient, which is 4. You have to square it. 16, and you put it here. Okay, now, at this stage, I've changed the equation, which is illegal. You can't do it. Whatever you do to the left side, you have to do to the right side. So if I've added 9 over there, I have to add 9 over here to keep it balanced. Remember, this is a balanced scale. I've just added 9 over there. Better add 9 over here to keep it equal. And we have to add 16 because we added 16 to the left. Okay? Does all this look familiar, I trust? Yeah. Okay, so pretty quick and easy with circles. And let's see. This is now going to be x minus 3 quantity squared. It's going to be y plus 4 quantity squared. And this is 25. Okay, so I've got it in the graphing form. The center, remember, was at hk. So for this problem, the center is going to be the ordered pair. You have to think this is minus k, so it's minus 4. And the radius is going to be 5, right? That's r squared. So we've moved the center. We're no longer at the origin, but we're now at the point 3, -4. Okay, let's get a little sketch going. What I would ask you to do on this is draw a picture and find the x and y intercepts. Okay, so let's see if we can do that. Graph paper comes in handy here. I'm just trying to do an accurate sketch. 3, 1, 2, 3, -4. There's my center point. Okay, and the radius is 5. So I would go up 5, 1, 2, 3, 4, 5. There's a dot there. I would go over 5, 1, 2, 3, 4, 5. There's a dot there. I go over 5 to the left, 1, 2, 3, 4, 5. There's a dot there. And I would go down 5. If I extend my page a little bit. 1, 2, 3, 4, 5. There's a dot there. Okay, so from the center point, I've gone 5 units up, down, left to right. And somewhere in here, there's a circle looking like this. Okay, now, question. Does it hit the x-axis? It does hit the x-axis. Find those 2 points. Go. Here's your equation. Find the x-intercepts. Make y 0. Just go into here, make y 0. Find the x-intercepts. They go pretty quickly. I've set this one up so that they're nice integers. Nothing's irrational. Find the x-intercepts. Okay, so we know we have something 0 and something 0 for x-intercepts. Remember, y is equal to 0, so that's how you're doing it. This is y equals 0. Okay, so find the x-intercepts. The 2 numbers are 0 and 6. Okay, 0 and 6. So that goes pretty quickly. Again, just go to your equation. We're making y 0. So this becomes now 4 squared. So we have x minus 3 squared plus 16 is 25. X minus 3 squared is 9. Take the square root of both sides. X minus 3 is plus or minus 3. So x is 3 plus or minus 3, which is 6, and 0. So those are the two x-intercepts. Find the two y-intercepts. Go. Find the two y-intercepts. Y-intercepts. Again, go to your equation, make x 0. Find the y-intercepts, and you're good to go. Okay. Should have an answer pretty quickly. Got it? Y-intercepts. Anybody? Yeah, we know one is 0, 0, obviously, because that's 0, 0, and the other one is 0, 8 up here. This is 0, 8 up here. Is that the one you want? So maybe 0, negative 8. You see where the negative sign comes from in your work? Did you do it? Okay, so, I mean, obviously you did it in your head. You gave me the answer. If this was worth 50 points, you would get 0 of the 50 because you had the wrong answer and there was no supporting work. If I could see the work, you might get 40 or 45 out of the 50 points, and you just made a sign error, so your answer's wrong, but I can see that you're doing the right stuff, so you get a lot of credit. Don't do stuff in your head. Put it on paper so I can see what you're doing. If you make a silly mistake at the very, very end, you're still going to pass. If all you have is the wrong answer with no work, it's a 0. There's nothing I can do. Okay, so yes, not 0, 8, but 0. Anybody else get 0, negative 8? I don't know. I haven't done it. I would hope it's pretty quick. I rigged this problem. We're finding the y-intercept, so make x 0. This becomes 9 plus y. 9 plus y plus 4 squared is 25. Y plus 4 quantity squared is 16. Y plus 4 is plus or minus the square root of 16. Y is negative 4 plus or minus 16. Y is negative 4 plus or minus 4, which is 0, negative 8. Okay, so those are the two y-intercepts. Okay. So when you see something that, here's another one just to practice with, you might want to play with this one tonight. There's a bunch of stuff in your book like these. Try this one. Again, I've rigged this to make it work a little bit nice. X squared plus y squared minus 4x plus 8y plus 13 equals 0. So your task is to find the center, the radius, the x and y intercepts. You should have this problem done in about 3 minutes. Try to do it now. We've got plenty of time. Center, radius, x intercepts, y intercepts. You also might want to look at a graph. In fact, I think the graph is something you should go at really quickly. Julia, question. If you have to go to the toilet, go ahead. We're going to go to mass in about 10 minutes and get it done before mass. Go. Okay? Find the x-intercepts, find the y-intercepts, look at the picture, center, radius, and it all goes together fairly quickly, I trust. That's the way you start. Put your gaps in, throw your constant to the other side, fill in the gaps. Fill in this gap with the right number. Hopefully that's 8. No, that's 4, right? Half of negative 4 is negative 2. Negative 2 squared is 4. And then put that over here. And then fill this guy in. That's 16. Right? Half of 8 is 4. 4 squared is 16. Put that over here. 16. So now you have it in graphing form or standard form. This is x minus 2 squared. And y plus 4 squared. And this is what? 20 take away 13 is 7. Okay? Anybody questions on completing the square? Okay, center. Ordered pair. 2, -4. Radius, square root of 7. Can you give me an approximation without a calculator? Is it more than 5 or less than 5? Between what two integers is the square root of 7? Not between 3 and 4, because the square root of 9 is 3. How about between 2 and 3? Right? 2.5. 2.5-ish. There. Okay? It's about 2.5. We okay with that? Without a calculator, everybody okay with that? Okay, let's get a little picture going before we go answering questions. The center is at 2, -4. 1, 2, 3, 4. So here's your center point. Now, do your radius. See whether you have x-intercepts and y-intercepts. Because if you don't have to find them. It saves you a whole bunch of work. Just draw a little picture going. Do you have x-intercepts? This is down here at -4. Let me draw my picture. This is at -4. Do you have x-intercepts? No, of course not. What's the radius? The radius is 2.5, isn't it? So if you're going up 2.5, the highest it's going to get is up here somewhere. You're not going to hit the x-axis. Are you getting y-intercepts? Yeah, because the radius is 2.5, right? So this is 2. 2.5 is going to put you somewhere over here. So it does look like we have a couple of y-intercepts. Find them. Find the y-intercepts. You're going to find these two y-intercepts. So x-intercepts, none. Y-intercepts we can find. Here's your equation. By the way, you can use this equation or you can use the original one. I sort of like the graphing form. It makes it a little bit easier to deal with. Find the y-intercepts, make x 0. 0 minus 2 squared plus y plus 4 squared is 7. So we have 4 plus y plus 4 squared is 7. So we have y plus 4 quantity squared is 3. Take the square root of both sides. Y plus 4 is plus or minus the square root of 3. And then go ahead and chuck the 4 in here. So y is -4 plus or minus the square root of 3. Which, when you think about it, sort of makes sense. We knew from the graph that this center point was at -4. And because it's a circle, there's no distortion here. We're going up a certain amount, we're going down a certain amount. This amount that we're going up is the square root of 3. So this point right here is -4, and we've added the square root of 3 to go a little bit higher. And then this point is -4. We've taken away the square root of 3. Now those are the y coordinates, and we know the x coordinate happens to be 0. So 0, comma, -4 plus square root of 3. Okay? So there's your y-intercepts. They don't have to come out to be integers. The first 2 or 3 examples I rigged to make them nice. This one's more typical. Comments on that, guy? Anything we've done there that you don't like? Okay. Ellipses. Hyperbolas. There's lots and lots and lots of similarities between ellipses and hyperbolas. Let me do an ellipse example, and then we'll do the hyperbola example, and you'll see they're almost the same. Here's a nice example. X squared over 16 and y squared over 9 is equal to 1. The hyperbola is going to be x squared over 16 minus y squared over 9 is 1. And again, if you just think coefficients for a minute, I can think this one as a coefficient of 1/16 x squared and 1/9 y squared is 1. Right, this is an equation that's just like that. If you go to everything you want to know, here's your, if A and B are the same sign but not equal, so I'm looking at the coefficient of x squared and the coefficient of y squared. In this case, they are the same sign, but they're not the same number. This is now going to be an ellipse. If this was a 1/16, now they are the same number, so what is this? A and B are the same number. It's a circle. By the way, tell me something about this circle. It's not very small. Say again? Right. If you multiply through by 16, you would have x squared plus y squared is 16. Centered at the origin, radius 4. Okay, so it's a pretty straightforward problem if these are the same number. We want to do it with these being different numbers. Okay? Now, here's how you're going to draw it. You're going to draw a box. Draw a set of axes. These examples today are centered at the origin. Tomorrow they'll be centered somewhere else. So let's start at the origin. In the x direction, go 4 units. 1, 2, 3, 4. 1, 2, 3, 4. And this is one dimension of the box. If you have graph paper, you're just thinking that's how long the box is. In the y direction, you go 3 units. 1, 2, 3. 1, 2, 3. That's the other dimension of the box. So here's my box I'm drawing. Now, the ellipse is going to fit inside that box. It's actually going to touch the edges of the box. So if I draw my ellipse, it's touching here. That's an x-intercept. There's another x-intercept. And we've got these 2 y-intercepts. Remember, if we didn't have the picture, you could still find the x and y-intercepts pretty easily. To find these x-intercepts, what do you do in this equation? To find x-intercepts, y is 0. So you make y 0, that goes away, and you would have x squared over 16 is 1, x squared is 16, x is plus or minus 4. Right, so those are your 2 x-intercepts. It goes pretty quickly. Same thing with the y-intercepts. Now, let's look at some terminology that you need to know. Think of this as a football. It's longer. This is the longer dimension. That's called the major axis. One of the things you would be asked is, how long is the major axis? Look at your picture and just count the boxes. It's 8. 8 long. If for some reason somebody asks, how long is the semi-major axis? Semi means half. So the semi-major would be 4. This is major. Half of that would be 4. Okay. The other dimension is called the minor axis. This is the minor axis. Minor axis. And in this case, it's 6 long. Right? Minor axis. Now, when you go to your handout, I'm calling this semi-major axis length. This distance here is called A, and this distance here is called B. You can sort of think of these as the radius of a circle. The radius of a, now that sounds a little weird because this is not a circle. But let's suppose just for a second we had a circle and it was centered at the origin, and we went a certain distance out, called it A, and we went the same distance out, A. Isn't that a circle? Say yes, that's a circle. What's the area of a circle, by the way? Area of a circle. Area of a circle. Pi r squared. But in this case, I wouldn't write pi r squared. I would write pi a squared, right? Because the radius is A. Right? You know the radius is A. Go to the ellipse. Anybody want to tell me the area of the ellipse? Area is pi, not AB squared. Okay, so for the circle, you're just not thinking. If this is A and this is A, the area is pi times A times A. What is the area of the ellipse? Pi AB. There you go. Those 2 semi-major and semi-minor numbers do a lot of things for you. They give you the area of the ellipse, for one thing. By the way, we can't prove this until next year in calculus. We can prove that. But right now, If this is 4 and this is 3, the area of this ellipse happens to be 12 square units. Okay, so that's a little piece of information you can use. There's another important piece of information coming from A and B. And let me give you this equation. C squared is A squared minus B squared. You'll want to remember this for ellipses. For ellipses, C squared is A squared minus B squared. And the C number, C, think focus. So in a ellipse, or in an ellipse, you have two focal points. The C is the distance away from the center. So for this problem, what is C? Well, this is my A squared, and this is my B squared. So for this problem, C squared is 7, right? Focus. C squared is 16 minus 9. C squared is 7. So C is the square root of 7. I'm thinking of it as a distance. I'm not going to do plus or minus. If you want to do a directed distance, you can do plus or minus. That's how far away from the center you go to put your focus point. Give me an approximation of the square root of 7. 2.5, some number between. Right. Okay. So here's my focus point. Focus. It's the square root. The other focus is over here. In the other direction, it's negative the square root of 7, comma 0. The two focus points. The plural of focus, by the way, is foci. You should know that. Foci. Okay. The two focus points are rather important when we come to ellipses, so know how to find them. One note that you should make, and again, it's on this page, so if you're not writing these notes down, when we get to ellipses, it talks about the focal distance, C squared minus A squared. The foci are always on the major axis. So if you have the picture, the focus points are on that major axis. Now, what are focus points used for? They determine the eccentricity. You might remember eccentricity from about 3 weeks ago. Eccentricity is C over A, square root of 7 over 4. I'll pick this up tomorrow right where we left off.